Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today we have reached the last problem in our Grind 75 coding series, that is finding the largest rectangle in histogram. So with this, let's just jump into the problem statement, understand it and start solving. Okay, last time we have solved it merged case sorted lists. I'll mark it check. You can find it in the list. And yeah, before finishing this, I'll just remind everyone that Grind 75 is one of the best coding series when you are preparing for any of your coding interviews, especially for the FANG level coding interviews, right? So with this, let's jump into the largest rectangle in histogram. Okay, given an array of integers heights representing the histogram's bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. Okay, 2 1 5 6 2 3. Okay, we have to find out which is the largest rectangle that we can form. As you can see, we could have formed a rectangle of height 1 and width, this complete width, that is 6. Sorry, this 6. 6 into 1 would have been 6, right? But that's not the max area that we can find. Max area would be 5 multiplied by 2, that is this height plus this height of 5. Okay, as they have shown here in the answer. Now the thing is, so the actual answer is on using stacks. If we see, this is a stack problem, but that is not very efficient, and yes, the efficiency was nearly about beating 5% of the solutions, right? So I then had to move to this other solution that I found. And before I go on and start coding, please take a minute and think of an approach that you would take. Ready? Okay, now what we can do is we can find out what is our height. Okay, and then we will always try to find out. So we would need one variable for keeping track of our maximum areas that we have found so far. Like for the first one, we'll find our maximum area would be 2. In the next one, we still have the maximum area 2, that can be 1, and this 1, right? When we reach to the third one, we can have 1 plus 1 plus 1, that is 3, right? Similarly, or not 3 actually, the length of this one 5. In the here we'll get the 10, 5 multiplied by 2. So we need to keep track of the heights, right? We need to keep a track of the heights that we have already covered, or the height that we have found, so that we know what is the maximum height that we have already found. And then we can use it to calculate the current height from these and simply multiply it by the width. So we need something to find the width of it, right? So with this, let's jump into the solution. Now it may be slightly really hard, but please pay attention and we'll start. Okay, so we would need a few variables. So what all do we need? Let's say int n is equal to heights dot length. Okay, now we want to have another array and we want to have a stack as well. Actually, we don't need a stack, but in order to improve the efficiency, we'll use an array as a stack. Okay, so we can say we'll simply say create an array stack, and we need one more array to keep track of heights, because when we want to put the heights of the increasing elements, like we have the height 2. Okay, that is the first array. Then we have height 1, then we have height 5, then we have height 6. We know the last 3 heights are increasing. Okay, when we are at height 6, we'll try to calculate the area as 5 multiplied by the previous max height multiplied by this width, that would be 5 into 2. Then we'll have the max area as 10. Then previous height, that is 1 multiplied by area, that is width, that is 1 multiplied by 3 would be 3, that is not bigger, right? So we need to keep a track of all these things. So we'll create an array stack, and we'll create one more array. Okay, why do we, or let's say one more modified array. Okay, so you can say int array stack. So this is an array, we're representing it as a stack, is equal to new int, and we need one extra size, and plus 1. Similarly, for the modified array, we want to cover the edge cases of the left hand side and the right hand side boundary condition. So we need 2 extra spaces, plus we'll initialize them with -1, so that when we start checking, the first number would always be bigger than the previous one. Okay, so we can say int modified heights is equal to new int n plus 2. Okay, now we'll initialize the first and last elements of our modified heights. Initialize first and last elements to be -1. Okay, so you can say heights, not heights, but modified heights of 0 is equal to -1, and similarly modified heights of what's the size, n plus 1 is equal to -1. Okay, now we'll simply copy. So we have this modified heights array. Let me show you what it would look like. Modified heights, and it looks something like this as of now: -1, -1, and in the middle, since the size is 2 extra, we'll copy this heights array. So the overall array would look like 2, 1, 5, 6, 2, 3. Okay, so let's copy. So copy the elements from heights to modified heights. So for int I is equal to 1, we'll start from the first index, since 0th index is already covered. I is less than equal to n, I plus plus. Okay, so n will take us till here, third, and this would be n plus 1. So we are only going till I equal to n. Okay, so we can say heights, not heights, modified heights of I is equal to heights of I. That's it, right? Now we'll initialize our array stack as well. So we'll initialize our array as well. So, or the first element in the array. Initialize the stack with first element first. So we can say stack of 0, not stack or array stack of 0 is equal to 0. Okay, now what all do we need? Okay, we need one more variable here, int max is equal to 0, to store our max area, or we can call it result. Int result is equal to 0. Okay, now we'll start with the iteration, and we'll go through our modified array, that is this one. Okay, so we can say iterate through modified heights. So for int I is equal to 1, 0 is covered, I is less than equal to n plus 1. Okay, I plus plus. Now what do we want to do? We want to fetch first our current height. Okay, so we can say int, that is too big, int current height would be modified heights of I, right? So for the beginning, we'll get our current height to be, since I is equal to 1 0 1 2, we'll get our current height to 2. Okay, that is the first height. Now we want to check from our stack. Okay, so we need one index for stack as well. So we'll say index for array stack int index is equal to 0. Okay, and okay, we are going to process the elements in the stack until our current element, that is this height, is greater. So same way, when we'll arrive at the height 6, we'll keep processing until this current height, our current height would be greater. Okay, so we can say process elements from the stack until current height is greater. So while now we want to fetch it from a modified heights, so modified heights of array stack of index, okay, is greater than current height. Okay, now let's do the dry run in parallel. So as of now, we have our array stack, so we'll take our array stack that has the values. Let's make this also square. Okay, that has the values as of now 0 0 0 0 0 1 2 3 4 5 6 7. Okay, now we didn't need to initialize here, but okay, so 0 0 0 0 0, everything is already initialized. Right, now we'll check modified heights, that is this one, array of stack index. So let's keep a track for index is equal to 0. So 0 0 is 0. If modified heights of 0, that is -1, is greater than our current height, so this -1 was for the left side base case, is it greater than our current height, which is 2? Let's keep separate variable here in current index, sorry, current height is equal to 2, right? Is greater than 2? No, right? If it is not greater than 2, then we'll push the current index. Okay, we'll push the current index of the found stack or found element onto the top of the stack or the top of the array. Now how we are pushing it on the top of the array? We are actually using the array and an index to always check the top element. Okay, so we can say push the current, not element, index onto the array stack, or let's keep it stack, or not, no confusions, array stack. So we can say array stack plus plus, first we'll increase our index and then enter it. Okay, is equal to I. Okay, so with this we increase the index value became 1. On the first index we saved the value of I, that is 1. Okay, now array stack, this will with the help of the index, the top element will always be this 1, right? Current height was 2. Now again, I is equal to 2, I got modified. Let's keep track here for the I. So I was earlier equal to 1, now that has been moved to 2. Okay, now current height from the modified heights, so current height would be for I equal to 2 would be 1, so we can say current height is equal to 1. Now is the we'll check what is the top index, the last index that we had, right? So we index value is 1, so array stack top would be 1. Now modify heights of 1 0 1 2. Is this height bigger than our current height? Right, so this height 2 is actually bigger than 1, right? Yes, the case is true. So now we'll bring the last top. Okay, we need to bring the last top from the, or we'll say the current top. Okay, we can say pop the top element from the stack, and we'll store them as the top. So current top will be array stack of index minus minus. We need to reduce the index value as well, so that always the top element would be there. We are using the index only to use an array as an stack, just to improve our overall time complexity, because the generic solution with using actual stacks was really slow. Not really slow, but was beating 15% of the solution, so not that good, right? Okay, so we'll get our current top. Let's keep a variable for current top as well. Current top is equal to what's the value? Index. So index was earlier 1. Have we reduced the value as of now? No, right? I've almost forgot. Did we reduce this index value? That's why you should always use commas. Okay, so I don't think we have reduced the value. The index is 1. Okay, let's see, 0 1 was entered here. Yeah, index is 1. So array stack from 0 1 will get 1. So current top is equal to 1. Index value will get reduced to 0. Okay, now we got our current top, that is 1. That is this height, if you see. Okay, now we will try to calculate the area. Simple method. So calculate max area and update if it is greater than previous max. So we can say, what is our variable? Result is equal to math.max of the previous result that we have, and I minus, where do we want to fetch the value from? Array stack dot index minus 1. Okay, and then multiplied by the height, so that we can get from our modified array. Modified heights, oops, heights, modify heights of, modify heights of current top. Okay, let me expand this a little. Okay, so what is the value of I right now? Value of I is 2 minus array stack of index. So index value is 0, so at the 0th we have 0. 2 minus 0 is 0. 2 minus 0 is equal to 2. Sorry, 2 minus 0 is 2. 2 minus 1 is 1. 1 multiplied by current top height. Okay, so if we check, current top is 1, so current height, the last height that we had was 2, right? 2 multiplied by 1 is equal to 2. So we found that as of now the maximum area that we have is 2. So we'll update our result, which was previously 0, now to 2. Okay, now we found a result. Again we will check if there are other values before this that were available of this height, that were greater than this height, that we can still calculate the area for. But if we check now, the array stack index value is 0, modified array of 0, that is minus 1. Is it greater than our current height? Because before this we have minus 1, right? Current height is 1, so no, that is not greater than our current height. So we'll move forward. We'll increase the index value will become 1 again, and we'll add I to it. So 0 1, and we'll add the value of I, that is 2. So now 2 is on the top of the stack, right? Similarly, we'll move forward. Now I is equal to 1, I is equal to 2, I is equal to 3. Okay, current height is equal to be modified of I, that is 0 1 2 3. We got the current height as 5. Okay, now array stack of index. So index is 1 0 1 2, heights of 2 0 1 2 1. Is 1 greater than our current height? No, right? That is not greater than our current height. So we'll push it on the stack. So we'll say index plus plus, index will become 2 0 1 2, and we'll insert I on it. The value of I is 3. So 0 1 2. Here we'll insert the value of I, that is 3. Okay, now again I will move to 4. Current height will be modified heights of I. So 0 1 2 3 4. Current height is 6. Now modified heights, array stack of index. So array stack of index, what is the value of index? Index value is 2. What can we check in the array stack? That is 3. Value of 3 0 1 2 3 from the heights, that is 5th, previous height. Is it greater than our current height? No, right? Previous height is not bigger than this height, so we'll move forward. So similarly, we had skipped this one because the previous height was not bigger than current height. Again, previous height is not bigger than our current height, so we'll move forward. We'll increase the value of index. So index value will become 3, and we'll add the value of I on array stack. Value of I is 4. So here 0 1 2 3, it will have the value 4. Okay, now value of I is 5. Current height will modify heights of I. So 0 1 2 3 4 5 2. Current height is 2. Okay, current height is 2. So we'll check array stack index. So index is 3 0 1 2 3 4. Modified heights of 4 0 1 2 3 4. We found the value 6, right? Now when we arrived at this bar, we checked for the previous higher bars, that was 6. We found the 6 bar. Similarly, we will check for 5 and previously, right? Now we found 6. Now since 1 is smaller, 1 will not be checked, but 6 and 5 are bigger than 2, so they will be checked. So we found 6. 6 is bigger than our current height. Current height is 2. Yes, that is bigger. So we'll change current top would be array stack of index minus. So array stack of index, what is the index values? 3 0 1 2 3. So current top will be 0 1 2 3, that is 3 here, and index minus, so index will become 2 again. Okay, now again we'll check the same result. That will be either the previous result, that is already 2, or I. What is the value of I right now? 5. So we can do a simple calculation here for just for sake, or let's do it here. 5, I'll keep them in brackets, 5 minus, okay, 5 is this height, minus array stack of index. What is the value of index? 2 0 1 2 3. 5 minus 3 minus 1, and that will be multiplied by modified heights of current top. So current top is 3. Current top is 3. So 0 1 2 3 multiplied by 5. Okay, so now we are going to multiply 5 with this current bar, that is multiplied by 5. 5 minus 3 4 minus 1. So 5 minus 3 2 minus 1 1 multiplied by 5 is equal to 5. So we got 5 is bigger than our previous result, so new result will be 5. We'll remove this part. Okay, so up till here we have found that 5 was the biggest height, but that we found on the second bar. Now we'll check for the bar previous to it as well. Now again Modified heights array stack of index value is 2, so 0 1 2 3. Modified heights of 3, 0 1 2 3. 5 is bigger than our current height is 2, yes, even this bar is bigger than this bar, right? So current top would be array stack of index is 2, 0 1 2 3. Current top will be 0 1 2 3. Somewhere I missed it. Let me check. We had reduced the index value, that is 2. What did we take last time? Let me do a command Z. Okay, so index value was reduced. It will be 1. No, sorry, index value is not reduced. Current top is wait, sorry, give me a second. I messed up in my own code. Okay, current top is array stack index minus, so index value is 2. We got the current top as 3. Current top is 3. It will be updated to 3 only. Now result will be max or I. Value of I is 5. We are still in the same loop. 5 minus, and after this index value was reduced, so index became from 2 to 1. Array stack of index 1, so from array stack 0 1 we have the value 2. 5 minus 2 minus 1 multiplied by modified heights of current top is still 3, so height is still 5. Now this will become 5 minus 2 minus 1 will be 2 multiplied by 5 is equal to 10. Okay, so 10 is bigger than our previous result, that was 5, so it will get modified to 10. Similarly, we'll keep moving forward, and for all the heights that are bigger than our current height, we'll check the solution, right? Since there will be no longer bigger heights more than 2 on the left hand side, we'll move forward to 3, and in the end we'll find out that the max answer could only be 10 that we have already encountered as of now. So that's it from this video. And yes, overall time complexity would be O of n. I do understand the solution is little complicated, but please, I did a dry run for everyone to understand, so please go through this video again, understand it one by one, how we are calculating the area, and then you are good to go. Okay, so yeah, that's all from today's video, everyone. For anything, please let me know in the comment section, or if you have a we almost didn't run it. Please, my bad. Let's see. Okay, somewhere something is not right. Cannot find symbol I. Why? Oh, I did it outside the for loop. Okay, let's command X and V. Oh, we haven't written a result anywhere. Return result. Run. Array index out of bounds, 6 out of bounds. Okay, somewhere something is not correct. Let's check that quickly. On this one, what was the problem here? Oh, why will we take height of I? Height of I has to be -1. Okay, let's run. Okay, let's submit. Great. Though I was thinking it would be still much better, because after picking up with this complicated solution, it should have been much better. We'll submit it again. We'll just check. It's already at good. So yeah, that's all. Yeah, it's the same. So that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.